14? All right, on number 14. Okay, what's the common base?
5.
All right, so if I do 5, (625) is 5 to what power? What is it? 4? So if I have 25 is 5 to the second, is that 7p? Yes? Minus or plus? And what is this? 3 minus? And then I get this 1. And I get a 1. But I know I have to have it as a base of 5 because these are 5s. So 5 to what power equals 1? 0. So once I put 0 here, now these are all common bases. So now I'm going to multiply this. So I get 14p minus 4 plus 12 minus 8p equals 0. Add and solve. So I'm going to get 14 minus 8 is going to be 6p. And then plus 8 is 0. So when I subtract the 8, it's not hard. Okay? So now what we're going to do today, this was exponential. So we had to have these all the same bases, correct? So for today, we're going to do logs. And you have to have all the same log, and it was going to work the exact same way. What? Why would I stress you? Well, I worked one on here instead today. But I don't want to stress you. But we did one here, so put that here. Okay, now you're here, and your brand new calculator right here. There's your pencil. Okay, so this is how this is going to work. So yesterday when the exponent bases were the same, we could solve the exponents, right? Now when the log is the same, we can use this equal to this when these are the same. So there can only be one log, so then I get 7x minus 1 equals 5x plus 17. And we just solve. So I'm going to subtract the 5x. Yes. So I was just thinking of, so I get 9 as an answer. So before we go any further on your handy dandy brand new very cool calculator, everybody take the log of negative 9. What does it give you? Okay, so the on button is up on the right. It's totally at the right. It says error. What? First of all, you have to use the negative sign, which is blue. Blue, above the recall button. Oh, black, whatever. So what did you get? Error, because you can't take the log of a negative number. So when we do this today, we have to make sure, whatever your answer is doesn't make this negative. Okay? So if I put 9 in here, 9 times 7 minus 1, that's going to be positive, and this is positive. So 9 is going to work as an answer. Okay? So the next one. I do not. I don't know what the problem is here. Yeah, this is hard. All right. So these are equal, so I can set this equal to this. And unlike this one, when we just had a variable, we put the variable on one side and the number on the other. This time, we have to move everything over to the squared side. So I'm going to subtract the k and then subtract the 14. And so when I do that, now this factors. So my k equals 7 and negative 2. So will either one of these make anything up here negative? So if I put negative 2 here, I get 4 and then plus 8. So that's positive and this is positive. So these are both going to work. I don't know what the problem is here. This is going to take us all day. Okay, so the next two. You have to make one log. So what does the plus mean? Multiply. So I'm going to get log of 4. Once I have log equal to log, I can set them equal to each other. So when I multiply, I get 4c plus 12 equals 8. Subtract the 12. Divide by 4. I have c is negative 1. Does it make anything negative up here? No, no, and no. So this is the answer. So here, what does the subtraction sign mean? So I'm going to have log base 7 of w plus 6 over 5w minus 3. And what does the 1/3 do? Where does that go? It goes up to the 8. So 8 to the 1/3, that's the cube root of 8. What is the cube root of 8? 2. So I get log base 7 of 2. So now I can set this equal to this. So I'm going to have w plus 6 over 5w minus 3. It equals 2, and I'm going to put a 1 under it. And so we would cross multiply and solve. Does anybody need me to cross multiply and solve? Oh, yeah. Okay. So when I do that, I get 10w minus 6 is w plus 6. So what's next? So w is 4/3. I know. Okay, so on number 5, I have this 1/2 here. Where does the 1/2 go? It goes to the 16 and to the 4. So I'm going to get log base 4 of 4p plus 3, and then I have log base 4. So if I put the 1/2 on the 16, what does that mean? the square root. What's the square root of 16? 4. And then I have p to the 4th times a half. So if I put a 1 under it, then I have 4 over 2, which is p to the 2nd. So I get 4p plus 3 equals 4p squared. I move everything over to the p squared, and I factor. So I'm not going to finish that one. That's how you would finish it. We have a lot of examples left to do. But number 6 I want to do. So first of all, I'm going to take the 2, and it has to go, this is in parentheses, so it has to go here, right? So I'm going to get ln of a plus 1 squared. Then, this is division, right? So I have ln of 80 over 5, and I have to raise it to the 3 halves. So now I have ln on both sides, so I'm going to get a plus 1 times a plus 1. And on this side, 80 divided by 5 is 16. And then I have the square root. What's the square root of 16? 4 raised to the 3rd power is 64. So when I multiply, this is what I get. Why? You'll just have to find it. But it works better, I promise. So this is what I have. So what do I do? Wait, before I go on, are you having trouble getting the 64? Is that what you're having trouble with? All right, let's make sure we can do that, okay? So if I do 80 divided by 5 gives me 16. Now I need to raise it to the 3 halves. So let's find. Above what? Oh, it's above the sign? Yeah. And so look, you can even, there's even a fraction that'll make it a fraction for you. Right, and that makes it 64. I told you, you guys are going to like this better. Did you find the fraction one? Okay, so on this one, that was one of the things we liked better about this. You don't have to do all the parentheses. Like the parentheses aren't going to throw you off on these. So did everybody see you can make it, you raise it to the power. It's right next to the log or above the sign. That raises it to the power. And then underneath the CALC, underneath the calc button, that's a fraction button where you just type in the 3 over 2. So does everybody see that? Okay. Okay, so now I'm going to subtract the 64. And I can factor. So my A's are negative 9 and 7. So now you need to test and see. It makes this negative, doesn't it? So you can't use it. So your only answer here is 7. So the negative 9 is extraneous because it makes that negative and it makes it not a solution. Does that make sense? So, I'm sorry, say that again? Shh. I think it's a good question, actually, but I'm not positive. So like if this was a 10, Is that what you're asking? Yeah. If this is a 10, it's positive and you can use it. So it's a good question. So the negative 9, if this was a 10, that would be positive and we can use it. But it's a 1 and this is negative, so we can't use it. Okay? All right. Okay. So listen, I'm going to move a little faster this time, and contrary to what you want, I'm not working all of them. I'm going to set them up and you finish them on your own. Okay, so what's the difference between this one and what I just did on the last page? Is there a log here? No. If there isn't a log here, we have to make it an exponential. So we're going to use the circle thing, which is we're making it into an exponential, right? I'm changing it from log to exponential form. And so that would be 2 to the 7th equals 3x minus 4. Use that handy dandy new calculator. What is 2 to the 7th power? 128? So x is 44. On number 8, what is my base here? E. So find the E on there because this is e to the 9th equals 2a. So you have to take e to the 9th and divide by 2 to get your answer. And if you do it correctly, this is what you get. So that's your shift button. You use what? Where is it? Oh, there it is. Where? I use the shift button. Where's yours? Okay, so look, y'all, some of you are using the E at the bottom. If you go where it says ln, if you use the shift button, it's e to the x power, so it's already raising it to the power for you. So you can use either one. So did y'all find it? Okay, did you get this answer? Okay. Okay, then we'll have to move on. All right. So starting on number 9, you have to have the log by itself. So I'm going to add the 5. Is there one log now? So you switch it to exponential, which is 6 to the 2nd power is w plus 7, and then you solve. On number 10, is the log by itself? No. So I'm going to subtract the 4. Is the log by itself yet? No, because it's times 2. So I'm going to divide by 2. Now is the log by itself? If the log is by itself, we can change it to exponential form, which would be 9 to the 1/2. That's the same as what? Right? It's the square root of 9, which is 3. So I get 3 equals k squared plus 2. I dropped a k, sorry. So plus 2k. So we're going to subtract the 3 and factor. Okay, let's do number 11. What does the plus mean? So I get 2v plus 3 times 2v minus 3. Is the log by itself? Once the log is by itself, we're going to switch it to exponential. So this becomes 4 to the second power (2v plus 3 and 2v minus 3). So what is 4 to the second power? 16, and then we're going to multiply on the other side. So what do I quit? I'm tired. I don't want to do anymore. None of the above. Minus the 16. So it factors to 2v plus 5 and 2v minus 5, which makes my answers 5 over 2 and negative 5 over 2. And I have to check and see if anything becomes negative if I use the negative 5 over 2. So if I put negative 5 over 2 here, if I put it right here, I have 2 times negative 5 over 2. What happens to the 2's? And that leaves me with negative 5 plus 3. Is that negative? So that is not an answer. So your only answer for this one is a positive 5 over 2. I can't have the negative. I can only have the positive answers. The negative is an extraneous answer. Only the negative ones. Okay, I just want to set number 14 up, and then I'm going to be done. So what does the subtraction mean? So I get log base 2, and I get c squared over 3c minus 5 equals 2. So am I down to 1 log? So after you're down to 1 log, you have to switch it to exponential form, which means I take 2 to the second power, and 2 to the second power is, and if I put it over 1, can I cross multiply, and then you're going to end up factoring again.